This is chapter 2 of class 10 polynomials. So we have already learned in our previous classes the polynomials of 1 degree and also what degree means when we have one variable. So 1 degree means linear. So we have discussed about the degree. What is the degree if you have a polynomial and you have variable? The highest power of this variable is known as the degree. So we'll discuss about the degree, which is the linear polynomial. So for example, this one is linear. These one all are linear because we have x to the power 1, y to the power 1 like this. And the polynomial like this, these are not linear polynomial. Why? Because they have x to the power 2, x to the power 3. So what we discuss here is that 2y square minus 3y plus 4. This is polynomial of degree 2. This is polynomial of degree 3. This is polynomial of degree 6. And these expressions, they are not polynomial. They are not considered to be a polynomial. So polynomial with degree 1 is linear. A polynomial with degree 2 is called the quadratic polynomial. Quadratic term or this word has come from the word quadrat, which is meaning square. This is square. So this square, y square or x square, all these you see the maximum power is square. These all are quadratic polynomials. These are quadratic polynomials. So if you have an equation of form ax square plus bx plus c, where this a, b, c are real numbers, then this is called the polynomial. But if we have a polynomial with degree 3, then we call it as a cubic polynomial. We call it as a cubic polynomial because the highest power is 3. Highest power is 3. So this ax cube plus bx square plus cx plus d, this is the cubic polynomial. Why it is cubic polynomial? Because highest power is 3 and you should know that a should not be 0 or a cannot be 0. Otherwise this will not be a, because x cube power will vanish and this will not remain as a cubic but it will become a quadratic. Now, if I place some value at x, let us place x equal to 2 here, means x equal to 2. We say px is our polynomial, we place 2 here. We place x equal to 2 at each and every place. So p2 becomes minus 6. Now minus 6 has come. How about p0? If we place 0 here, x equal to 0, it will be minus 4. But there is one more thing. At some point, if this equation becomes 0, let us take an example. If we place x equal to minus 1, if we put x equal to minus 1, this p minus 1 will make this equation 0. Again, if we place x equal to 4, this equation will again become 0. So at this k or at certain values where this equation, quadratic equation for example, is becoming 0, we call them as zeros of the quadratic polynomial. In later classes you will also know this by the name of roots. Right now we call it as zeros of the quadratic polynomial. So a real number k is said to be 0 of a polynomial if it makes this equation as 0. And as we have seen in the earlier class how to easily solve this linear polynomial, if px is equal to 2x plus 3, then we just put 2x plus 3 equal to 0. So 2k plus 3 equal to 0 means k is equal to minus 3 by 2. Right? Ax plus b, just place k and we say that k, just put a k plus b equal to 0, it will be minus b by a. So this is nothing but minus b by a only. So the 0 of the linear polynomial ax plus b is nothing but minus b by e, that is the negative sign of the constant term, which is the 3 here, which is the b here, divided by the coefficient of x, which is the 2 here, which is the a here. So either it is minus 3 by 2 and if you want to generalize it, it will be minus b by a. So the 0 of linear polynomial is here related to the coefficients. Now, is it true for quadratic? Is it true for your Third one, that is cubic also. Is it true? Let us try and also answer this query. What is the geometrical meaning of zeros of a polynomial? If you have a linear equation like this, ax plus b, just make it some value y is equal to ax plus b, and we know this is a straight line. And this straight line, these are your axes. This straight line will be like this. This straight line can be like this, or it can be like this. Any way it can be. It is going to intersect at x-axis. See, all these are intersecting at x-axis. This can be like this also, parallel also. It will not at all touch or intersect the x-axis. But the zeros of any equation of this sort is that point where this line intersect the x-axis. So this is the x coordinate actually. For example, if we take this y is equal to 2x plus 3, and we see that this line passes through these two. We place x equal to minus 2, we get y equal to minus 1. We just place minus 2 here, we get y equal to minus 1. We place 2 here, and we get y equal to 7. Let us make a line, because we have now got the 2 points. Just straighten the line, and we see here that when we straighten the line, it intersects the x-axis at minus 3 by 2 comma 0. This is the point here, minus 3 by 2 comma 0. Minus 3 by 2 comma 0. So the x, this point x, this where the y-axis is 0, means y coordinate is 0. This is the point we are interested in, and this is what we call as the zeros. So the ax plus b, y is equal to ax plus b, exactly it intersect at one point, that is minus b by a and 0. Now you know the 0, this is the 0. Now let us go for the quadratic polynomial. Just consider this quadratic polynomial x square minus 3x minus 9 minus 4. Again we'll do the same thing. We'll put some values for x, which is origin and somewhere near origin. We take y, we place minus 2 here, minus 1 here, and corresponding value of y we need to find out. So there will be a curve, and this is the curve. We generally know it by the name parabola, and this can be of this form. If ax square plus bx plus c, a is greater than 0, then this is of this form. If a is less than 0, it is of this form, right? So as we see here, this particular curve intersect at these 2 points with the x-axis. So these are 2 zeros here, minus 1 and 4. So minus 1 and 4 are the zeros or roots of this equation, which is represented by x square minus 3x minus 4. So we have 2 zeros. So at most there can be 2 zeros for ax square plus bx plus c. There can be various cases, as you will see, that this graph which we have just seen, it cuts or intersects at 2 distinct points. This is a curve intersecting at this point and this point. Again, this curve intersecting at these 2 points. This is the case 1. Now case 2, this curve is not intersecting, but it is intersecting or touching at one point. So here we have 2 roots or 2 zeros. Here we have just 1 zeros. In this case, it is not at all touching the x-axis or intersecting. So this equation has no zeros, or it has no point where the y coordinate becomes 0. So this equation has no 0. Now we conclude that the quadratic equation can have at most 2 zeros. So what do you expect for the cubic polynomial? Let us take an example. X cube minus 4x will do the same thing. We'll place some values at x and we'll try to find out the value of y. So you see here, y is equal to x cube minus 4x. When we draw it, we see that this point, and this point means these are zeros. So you get minus 2, you get 0, and you get 2 here. Minus 2, this, and 2. So now these three are points These three are points. We call it as 0. So these are 3 roots or 3 zeros. Here we have just 1 0. Here we have 1 and 2 zeros. Now we conclude for the cubic there can be at most 3 zeros. At most means there can be no zeros, there can be 2 zeros, there can be 3 zeros. And in general, if you have a polynomial of degree n, highest degree n, the maximum possible roots or zeros can be n. Now let us look at this graph or these graphs and try to find out the number of zeros. So here it intersected 1 point, so here we have 1 0, 2 point, 2 zeros, 1, 1, 2, 2 and 3, 3 points, 3 zeros, 1 point, 1 zeros, 1.10, 1, 2, 3, 4, 4 zeros. We have seen about zeros, how we can find zeros up till now. Now we'll see the relationship between zeros and coefficients of a polynomial. So a linear polynomial of this type ax plus b, we have seen that the solution or the zero is minus b by a. We have to recall that in our earlier class 2x square minus 8x plus 6, if we take an example, then we can find out the factors of this equation. How you are going to find out? This minus 8x is represented in terms of this 2x square and 6. So this 6 and 2x square is 12x square, and 12x square can easily be written as this 12x square can be taken, and minus 6x and minus 2x actually gives minus 8x. Minus 6x minus 2x, if you multiply, you'll get this. So ultimately what you have done is you have arranged it so well that you can take 2x out and x minus 3 inside. Again you can take minus 2 out from here, x minus 3. Now you can take out x minus 3 as a whole, and you will be left with 2x minus 2. You can take 2 out also. So now this equation has 3 factors: 2, x minus 5 and x minus 3. 2 cannot be 0. Let me tell you, 2 cannot be 0. So for zeros, either x minus 1 has to be 0, means x minus 1 will be 0 and x minus 3 will be 0. So the solution would be x equal to 1 and x equal to 3. So we have solution as x equal to 1 and x equal to 3, putting x minus 1 equal to 0 and placing x minus 3 equal to 0. So the zeros of these are 1 and 3. Let us sum them. 1 plus 3, that will be 4. And let us also take the coefficient of x, which is minus 8, and divide it by the coefficient of x square, that is 2. Minus of minus 8 by 2, and this is minus of 8 by 2. And you will be surprised that this is exactly same as the sum of its zeros. Again, product of zeros, that means 1 into 3, that will be 3. Now take the constant term and divide it by the coefficient of x square, 6 by 2. Again, this is again 3. So the product of zeros can be written as constant term divided by coefficient of x square. So we have used the splitting term. We can take one more example: 3x square plus 5x minus 2. Split the middle term, you will find these factors. Now place this equal to 0, this equal to 0. So x will be 1 by 3 and x will be 2, minus 2. So minus 1 by 3 and minus 2 are the, you can say, zeros. Now let us take the sum. You'll get the sum, and this is exactly equal to the minus of, if I take this ax square plus bx plus c. So this is nothing but minus b by a, and this is nothing but c by a, the product. So we can just generalize it that if alpha and beta, these are the zeros of the quadratic polynomial ax square plus bx plus c, and x minus alpha and x minus beta are the factors of this, then ax square plus bx plus c will be equal to k, because we know k will take as any constant. So let us take k as constant. We will make it 1 in the later discussion. But just to formalize it, k can be anything. This will be equal to, because these are factors, so it will be equal to x minus alpha, x minus beta. Let us arrange them. So this will be x square minus alpha plus beta plus alpha into beta. So alpha plus beta is what? Take k as 1 now. just take k as 1. So alpha plus beta is nothing but minus b by a. Alpha into beta is c by a. This is the solution. If you solve this, if you equate it with a, this with b, and this with c, you'll see alpha plus beta is minus b by a. Alpha into beta is c by a. So this is minus coefficient of x. We are considering ax square plus bx plus c. Sum of zeros is alpha plus beta. This is minus b by a, and product of 0 is c by a. Let us take an example. We have to find the zeros of this equation or this polynomial, and we have to verify also the relationship between the zeros and the coefficient, which we are discussing in this section. So x square plus 7x plus 10 can be written like this: x plus 2, x plus 5. Place it 0 because we want the 0. So x will be x plus 2 equal to 0, x plus 5 equal to 0. X will be minus 2, and x will be minus 5. And minus 2, minus 5, just sum them, product them, and take minus b by a, c by a. This will be exactly similar. This we have verified. X square minus 3, we have to find the zeros of this. We know that you can write it as root 3 whole square, because 3 is nothing but root 3 whole square. And we know a square minus b square is what? A minus b, a plus b. So this will be x minus root 3, x plus root 3. These are the factors. Now to find the zeros, put x minus root 3 equal to 0, so x will be root 3. X plus root 3 equal to 0, that is x equal to minus root 3. So these are the two roots. Add them, subtract, and multiply them. We'll get minus b by a, which is equal to 0 only, and c by a, which is minus 3 by 1, that is minus 3 only. And one more question is there. We have to find the quadratic polynomial. The sum and product of whose zeros are given like this. So alpha plus beta is given minus 3. Alpha into beta is given 2. Equate it with minus b by a and c by a and just solve it. You'll get, if of course if we take a equal to 1, then b equal to 3, c equal to 2. So this is the x square plus 3x plus 2. Now you will ask me why you have taken this as 1 or k equal to 1. This is one solution. If I multiply it by 2, this will become 2x square plus 6x plus 4. This is another solution. So there can be multiple solutions or multiple type in which this equation can be represented. Now let us come to the cubic polynomial. So is there any relationship between the zeros and the coefficient in terms of cubic polynomials? Yes, it is. So if we take px as 2x cube minus 5x square minus 14x plus 8, and if I tell you that these are the solutions or these are the zeros, just take sum these, and you'll be elated to know that this is equal to minus coefficient of x square by coefficient of x cube, which is similar to sum of zeros. If you take the product of zeros, then this will be minus 4, and if you also do the minus of constant term divided by coefficient of x cube, this will again be equal to minus 4. One more thing, if you take them pairwise, means multiply them pairwise, 4 into minus 2 into half, and 4 into half pairwise, and then you add them, you will get this value. And this is exactly equal to the coefficient of x divided by coefficient of x cube. So what we have found out by this discussion is, if you have a cubic polynomial of this form, then if alpha, beta and gamma are the zeros, then alpha plus beta plus gamma is minus c by a. Alpha, beta, beta, gamma, gamma, alpha addition is c by a, and the product of these three zeros are minus d by a. Let us verify that these three are the zeros of this. So the best way to verify, first of all, is to put this value here in this expression. If you get 0, then it is okay, and you'll get it 0. You can just try it. But after this, you see that alpha plus beta plus gamma, if you add them, you'll get minus b by. That is minus of minus 5 by 3. If you pairwise multiply and add, you'll get c by a. If you multiply them separately, you'll get minus d by a, which is equal to 1. How about division algorithm for polynomials? So the division of this algorithm or division algorithm for polynomials, let us take this. Okay. Now, if we tell you, or I tell you that this equation or this polynomial has one of its zeros as 1, means x minus 1 equal to 0, that means that only x equal to 1. So 1 is the solution. So x minus 1 is the factor, right? X minus 1 is the factor. Now the second one, let us divide them, these two, and we'll divide it just now, just by saying that if you divide x minus 1 or x cube minus 3x square minus x plus 3 by x minus 1, you will get this value, x square minus 2x minus 3, which is called the quotient. Now x square minus 2x minus 3 can be represented like this, x plus 1 x minus 3, we have just factorized it. So the solution or the zeros will be something like this. X minus 1, I have already told you that this is the solution. X plus 1 and x minus 3 you found out from here. So these are the three zeros of cubic polynomial. So 1, minus 1 and 3. Now this has come when I told you, let us solve it. So how to solve it or how to get the solution? Let us take an example. X plus 2, we want to divide this by this. So x plus 2, 2x square plus 3x plus 1. What you have to do here is, you have to take this 2x square, divide it by x. What you get? 2x. So you place 2x here. Now multiply 2x by x plus 2. So 2x square plus 4x. You place it here. Subtract. This will get cancelled. This will be minus x, and you place this. Means write it like this. Again, this is what? X, and this is minus x. So minus x, take this, divide it by x. What you get? Minus 1. You place minus 1 here. And multiply minus 1 to x plus 2 and write it here. So this will be minus x minus 2. And then subtract or add, and then you get 3. Now you cannot go ahead. So this can be written as, actually 2x square plus 3x plus 1 can be written as, this is the dividend, can be written as divisor. What is a divisor? This is the divisor. And quotient is this, plus the remainder. So if you perform this like this, you will get 2x square plus 3x plus 1. Now, the procedure. We are trying to ask and suggest the procedure. So the procedure is exactly same. You want to divide this by this. Now this is cube, this is square. So you have to arrange it properly. You cannot just write like this. You have to take the highest power here. So this will be x square first, then 2x, and then 1. You can write like this. This remain like this. So now how to do? Just the previous discussion will apply here. First take this 3x cube divided by x square. What you get? 1 and 3x. So just place 3x here. And now multiply 3x by, complete this. So you get 3x cube plus 6x square plus 3x. So subtract this. This will get cancelled out. This will be minus 5x square. This will be minus x. And just keep it like this. Now, this is minus 5x square. This is x square. Divide it. Minus 5x square by x square. What you get? Minus 5. Place this minus 5 here. So this minus 5, now multiply minus 5 with this and keep it here. Solve it. This get cancelled. This is 9x. This is 10. 5 minus 5 is 10. Now, the power of x square, the power of x is less than x square, so we cannot proceed now. This is the solution actually. So this is how you get, and you will apply that. That is the divisor, dividend, and the remainder. So this you get exactly like this. So divisor into quotient, sorry, the quotient was there. Dividend will be equal to divisor into quotient plus remainder. So this is the Euclid's division algorithm. We are actually applying it. Again, let us take one more example. You have want to divide this with this. So you have to rearrange this. So rearrange first, minus x square first, then plus x minus 1. So we have written like this. and this is what we have to do. Again, we have to rearrange this also, because this is the highest power. So minus x cube will come here, then 3x square, then minus 3x plus 5. So we have a rearrange. Now we can divide. This is minus x cube, this is minus x square. So let us divide. What do you get? X. Place x here, multiply x with whole of this, place it here. Now do the subtraction or the addition. You can add, and this can be 2x square and this will be minus 2x. Now this is minus x square, this is 2x square. Divide. 2x square divided by minus x square. What do you get? Only minus 2. Minus and 2. Place minus 2 here, multiply this minus 2 with this and place it here. What do you get? All these cancel, 3. Now the power is less than this, or this is only x to the power 0. You have to stop it. And you can just verify it, divide it into quotient plus remainder, you will get the dividend, which is this one. So the division algorithm is also verified. Find all the zeros of this is equation or this expression. If you know that the two of its zeros are root 2 and minus root 2. So you know by now that x minus root 2 and x plus root 2 are the factors. Multiply them, x square minus 2. And if these two are factors, to find other factors, you need to divide this or this expression by this expression. So let us divide. X square minus 2 needs to divide this one. So what you have to do, take this 2x to the power 4 divided by x square. You get 2x square. Place it here. Multiply 2x square by whole of this, keep it here. And you have to keep the values which are having equal power. You cannot write 4x square here or here. You have to place it exactly with respect to the powers. So just subtract this gets cancelled out, this will be like this only, this will be like this only, this will be like this only, this will give you x square. Now this minus 3x square has come. Take minus 3x square divided by x square. What you get? Minus 3x. Place minus 3x here. Multiply minus 3x by this and place it accordingly. So you'll get minus 3x cube 6x. This gets cancelled out. This will be here. This will be here. This will be 0. Again, you get x square here. Take x square divided by x square. So 1. Place 1 here. So 1 has come. Multiply this whole by 1. So it will be x square minus 2. This gets cancelled out. You get 0. So now you have got this also. So one factor is x minus root 2, other is x plus root 2. So we have combined these factors. So we said that x square minus 2 is a factor. But we have this expression which has come. So now solve this. You have to solve 2x square minus 3x plus 2, and you can factorize it. The value will be 2x minus 1, x minus 1. So just place it 0, place it 0. X will be half, x will be 1. So we have 4 factors: root 2, minus root 2, half, and 1. So let us summarize what we have learned up till now. The polynomials of degree 1, 2, 3 are known as linear, quadratic, and cubic. The quadratic polynomial is of this form: ax square plus bx plus c. A, b, c are real numbers. A cannot be 0. The 0 is where it cuts or intersects the x-axis. The quadratic polynomial can have at most 2. The cubic polynomial can have at most 3 zeros. If this is your polynomial, alpha and beta are the zeros or roots, then alpha plus beta is minus b by alpha into beta is c by. If you take the cubic equation and alpha, beta, gamma are zeros of this cubic equation, alpha plus beta plus gamma is minus b by, alpha beta plus beta gamma plus alpha gamma is c by, alpha into beta into gamma is minus d by, right? So this is the polynomial chapter of your 10th class mathematics. Thank you so much. Take care of yourself.